1. Define matter. Matter is anything that has mass and takes up space. Another way to say takes up space is that it has volume. Two, state 4 points of the particle theory of matter. There are more than 4. You can just pick any 4. So the number 1 should be all matter is made up of particles. And you now know that these particles are called atoms and molecules. Particles are always moving. I like to describe them as vibrating or jiggling. So even if the object itself doesn't look like it's moving, those particles that make up the object are always moving and jiggling. And depending on how much space is in between each of these particles, we can have either a solid, liquid, or gas. So another point is that there are spaces between particles. Okay, they're not really actually touching each other. There's always some kind of space in between particles. But they do hold on to each other in the sense that they are attracted to each other. So a fourth thing you can say is that there are forces between particles. And that's 4. There is another really important one that we talked a lot about in class, especially during our diffusion experiment. So I'll just add it here. If the test asks you this, you only have to put 4 on there, though. So the faster the particles are moving, the higher the temperature is, or vice versa. So temperature is directly correlated with the motion of particles. Higher temperature, faster motion. That's another way to word it. There's lots of ways to word it. Okay, question 3. Name the physical property that is described by the adjectives listed. So red, blue, and yellow, those are describing colors, which is a physical property. Usually if you're asked to state the physical property of something, one thing you can always go to is color. Salty, bitter, and sour, those would be tastes. Smooth, rough, gritty, that's how something feels, and the scientific word for that is texture. Solid, liquid, or gas, that's the physical state of the matter. And then pungent and odorless. So the answer is in one of the words already. We're talking about odor, or how something smells. The word pungent, if you haven't heard of that before, it means it has a pretty strong smell, strong and off-putting smell. Okay, define density. So I believe this was on your quiz before, and I expected you to write it as part of your lab report on the density of rubber stoppers as well. So the simple definition is basically based on the formula of density. It's the ratio of mass to volume of a substance. Okay, and the formula for it is D equals M divided by V. So now we'll use that formula to calculate the density of a 420 gram object that takes up 350 centimeters cubed of space. Show your work. So we can start with the original formula and then calculate it directly by filling in the numbers. So 420 grams is the mass, and 350 centimeters cubed is the volume. And so you have to know which number is which just by reading the words of the question. You can tell by the units. If it's in grams, it's a mass. If it's in centimeters cubed, it's a volume. Other volumes include meters cubed and milliliters. So we can divide this. I don't exactly have my calculator with me, but this one is the same as 1 and 70 over 350 if I write it as a mixed fraction. And 70 over 350 is the same as 1/5 actually. So this is a nice number. It works out to be 1.2 grams per centimeter cubed. So you do need to write the correct units of density. They look like this. There's always a slash in it for the units of density. It's some kind of a mass unit slash some kind of a volume unit. Okay, question 6. Determine the volume of an object with a density of 7.4 grams per centimeter cubed and a mass of 250 grams. Show your work. All right, so if you know the volume formula, you can write it out directly, or you can start out with the density formula and do algebra to get to the volume. So the algebra steps would be multiplying both sides by volume first. So the purpose of that is because now v divided by v cancels out, and now I do not have the volume variable in the denominator of a fraction. The next thing I'll do is divide both sides by density. So, well, first I'm going to rewrite what I have just to keep things neat. Okay, so that's what I have after the first step. And now I'm going to divide both sides by d. And the purpose of that is to cancel out d over d. And I'm left with volume all by itself on the left side of the equation. So those are the algebra steps. Now I'm ready to fill in the values. So that would be 250 grams divided by 7.4 grams per centimeter cubed. And again, I don't have my calculator with me, so I'm going to do some long division on the side here. Make sure you bring your calculator to the test. Okay, 250 divided by 7.4. I'm going to change this to divided by 74 because I don't want the decimal there, which means I have to add a 0 to 250 to make it 2,500. So this is the same division, 2,500 divided by 74. Okay, so 74 does not go into 2. It does not go into 25, but it will go into 250 3 times. So that will be 74 times 3 is 222. Because 4 times 3 is 12, and 70 times 3 is 210. So in total, that's 222. Then we do subtraction here. So that's 28. Bring down the 0. And how many times does 74 go into 280? That'll be 3 as well. You get 222. Subtract to get 58. Now I'll add a decimal 0 that I can bring down. So 74 into 580, I believe that can go 7 times, but not 8 times. So put a 7. So 74 times 7. So that's 490 plus 28. So that's 518. $62. Bring down another 0. Well, I'm going to stop there. I'm going to round my answer. So 33.7. There's going to be more digits after that, which I haven't calculated yet in my long division, but I'm going to just round 33.7 up to 34. The units of volume would be centimeters cubed. Okay, so that division took a long time. So key point, bring a calculator. All right, question 7, determine the mass of a cylinder with radius 1.2 centimeters, height 4 centimeters, and density 3.3 grams per centimeter cubed. Show your work. Okay, so with this, mass will equal to volume times density. You can discover that from the algebra steps that I showed for question 6, or maybe you just know the formula for mass based on volume and density. So to do this, I do need the volume of a cylinder. Okay, so I'm going to have to calculate that first. So I'll erase this. I'm going to start by calculating the volume of a cylinder. You will be provided with these formulas for volumes. So for a cylinder, it's pi times r squared times h. And I have just opened up the drawer to this desk, and there is a calculator in there, so I can do this a bit quicker. So this will be pi times the radius is 1.2 centimeters squared, and then the height is 4.0 centimeters. Okay, so I'm going to go on my calculator here. I'll push the pi button, multiply 1.2, multiply by another 1.2 because it's squared, and then multiply by 4, and that's giving me 18.1 centimeters cubed. So that's the volume, and then mass can be calculated by multiplying that volume by the density. It's 18.1 centimeters cubed times 3.3 grams per centimeter cubed, and that'll do it for you. So I'm pushing that in my calculator right now, and I'll round my answer to the nearest whole number. It's giving me 60. And don't forget to put the units on. These are the units of mass, which is going to be grams. Question 8, identify each element that is described. So this is more recent in our unit, based on information from the periodic table. So the element with 11 protons, that means the atom that has atomic number of 11, that would be sodium. You can either write the full name or you can write the symbol. However, if you choose to write the symbol, make sure that it's case sensitive. So it's capital N, lowercase a. The element in group 3 and period 2. So this was a typo, actually. We got a typo here. It should say group 13. So in group 13, in period 2, you look in the 13th column, the second row on your periodic table, and you will find that it is boron. The noble gas in the same period as silicon. So the noble gases are the term for group 18, column 18. So the very last column, you look for the one that is in the same row as silicon, and that will turn out to be argon. The smallest alkali metal. So you need to know what alkali metal is. And alkali metal means group 1 or column 1. Except for hydrogen. So if you write hydrogen as your answer, you get it wrong because hydrogen is not actually a metal. So the smallest alkali metal is element number 3, which is lithium. Element with 4 energy levels and 2 valence electrons. So you need to know how that's related to the periodic table. Energy levels are the same as periods or rows. So we're talking about row 4, and for valence electrons, that's determined by which group it's in or which column it's in. So we're looking for the element that's in row 4 and in column 2, and that turns out to be calcium. A period 3 element in the same family as beryllium. So likewise, period means row. So we're looking for a row 3, and you need to know what the word family means. Family means column. It also means group. So the same row 3 in the same column as beryllium. So that's actually the element right underneath beryllium, because beryllium's in row 2, so the one underneath it would be in row 3, and that's magnesium. Capital M, lowercase g. And finally, the most reactive non-metal. So this was our most recent lesson we had on Thursday. The most reactive non-metal is going to be a halogen, because they're the most reactive non-metals. But which halogen? It is the smallest halogen. That'll be the most reactive, and that is fluorine. So there it is. Question 9. Draw a Bohr-Rutherford diagram for each of the following atoms, assuming that they are neutral. So that's important. Neutral means same number of protons as electrons. Okay, so let's start with carbon. For carbon, you look on the periodic table, and it'll say C, it'll say 6, and underneath the atomic mass rounds to 12. Okay, so that's what it shows on the periodic table, and with that information, you can draw the Bohr-Rutherford diagram. We start with a circle for the nucleus. I'm going to write 6 protons and 6 neutrons. Because it has to add up to 12. The mass is 12, so those have to add up to 12. So 6 plus 6 makes 12. Then we draw the first ring, or energy level. That'll have 2 electrons on it. Then we need more, so we draw a second energy level. And that will have 4 electrons on it, because we need 6 in total. So that is the answer for carbon's Bohr-Rutherford diagram. Phosphorus, find that on the periodic table. You'll see that it's element P, which is element number 15. And the mass will round to 31. That may depend on which periodic table you have, but the one that I have, it rounds to 31. So we're going to draw the nucleus. We're going to write the protons, which are 15 of them. And then the neutrons, so protons and neutrons need to add up to 31. So 15 protons plus 16 neutrons, that'll make it add up to 31. Now I'm ready to draw electrons. So 2 on the first energy level. Now the second energy level can fit 8. 2 on each side, so I'll put all 8 because I need to get up to 15. So far I've got 2 plus 8, which is 10. I need to draw 5 more. Those are going to go on the third energy level. and we draw 5 of them. So you can draw 2 on one side and 1 each on the other 3 sides. You want to make use of all 4 sides if possible. So that's how we do that. Okay, question 10. What is the definition of a chemical reaction? So a chemical reaction has one criteria. You put things together, and if a chemical reaction happens, that means that a new product is formed. A new product is formed. From the reactants. So the reactants are what you put together, and the products are what you see afterwards. And if something new, a totally different compound or a different element results, then we have a chemical reaction. Now there's 4 signs that a chemical reaction has occurred. So one of them is a color change. Okay, most students seem to remember that as one of them, but how about the other 3? A production of a gas is usually a sign of a chemical reaction, and I'm going to say not due to vaporization, because we can vaporize something. We can boil water, for instance, and turn the water into gas, but that's not a chemical reaction. A precipitate is a sign of a chemical reaction, and that is a powder. From when you mix 2 liquids together, there's no powder in the liquids to start, but then there's these powder solid particles afterwards. That's called a precipitate, and that's a sign that a chemical reaction took place. And the last one, I'm going to call energy changes. So I'm talking about heat or light. So if something starts glowing, there's a sign of a chemical reaction. That can be like a glow stick or a flare. Or if heat is being produced, that's a chemical reaction as well. That can be something burning. Provide 2 specific examples of chemical reactions. Okay, so there's lots I can say here. I can talk about, I already talked about glow stick, so I can write that down. So the chemicals in a glow stick mix, and light is released or produced. Okay, it starts glowing, so there's a sign that we have a chemical reaction. And another, I'll use a classic one. Baking soda and vinegar is a classic chemical reaction. You can do it in the kitchen. And so those are the reactants, and in order for something to be a chemical reaction, you have to produce a new product. And well, when you put these together, it starts fizzing up, it starts bubbling up, so we did produce a new gas. And that gas happens to be carbon dioxide. I'll do a couple more maybe, just so you have some more examples as you're studying. So we did one with energy change. We did one with gas being produced. You can talk about a color change. So metal rusting would be a simple example of a color change. You can talk about a food rotting, that'll change its color. And precipitate being formed is maybe one I will not list out because there's nothing really, like there's no everyday common knowledge thing I can think of for that. I can only really think of some technical chemicals that we have in the lab, put them together, but that won't mean too much to you because you will not have heard of those chemicals. Provide 2 examples of physical reactions. So sometimes you can notice something happen, but you don't actually make a new product. There's no new particle, so it doesn't count as a chemical reaction. So then we're going to call them a physical reaction. And all of the changes of state, any change of state counts as a physical reaction. So for example, melting ice is a change of state. We did not change any particles. Ice is made of H2O particles, and so is water. So H2O turned into H2O, that's not a new product. So that's only a physical reaction. And then we can talk about things where you're not making something new, you're just kind of mixing things together. We did it with food coloring in the past. You mixed a couple of colors of food coloring and the colors mix, but it didn't turn into a new color. We can also talk about dissolving sugar in water. So basically you have sugar, which is a sweet, solid substance, and you have water, which is a bland, colorless substance. You put the sugar in water, and then you have sugar water. It's water that tastes sweet, and you didn't change any properties really. You still have the sweetness there, you still have the colorlessness there. It didn't suddenly change into some random color. It didn't suddenly start tasting salty or something different than what the sugar originally tastes like. So you did not actually make any new product. All the original reactants are still the same thing. It just, you don't see the sugar anymore because they're now hiding in the spaces between the water, but it's still there. So that's just a physical reaction as well. Describe 3 differences in physical properties between metals and non-metals. Okay, so if you understand what metals are, non-metals are often the opposite. So metals are shiny. Non-metals often are not shiny. Metals are usually conductive. Electricity can pass through them. Non-metals are typically not conductive. There may be some that are a little bit conductive, but not like metals. And finally, malleability and ductility would be another property of metals. Non-metals typically are not malleable. Cannot hammer them down into sheets. Okay, so yeah, those are 3, and ductility could have been another one. And those are physical properties. Don't accidentally talk about chemical properties unless the question asks you for chemical properties. For example, metals will react with acids. You put acids on metals. They will react and produce a gas. It's called hydrogen gas. Non-metals typically don't do that. But that's a chemical property. This question is asking for physical properties.